Welcome to Powertech Insights. In this tutorial, I'll guide you through perform a secondary injection test on the SPAJ 142C protection relay using the Overcurrent cpc100. Let's get started. Purpose of the test. Performing a secondary injection test on the SPAJ 142C protection relay using the Overcurrent cpc100 test system ensures the relay's proper functionality and verifies its settings. This process involves injecting precise current values into the relay's inputs and analyzing its response. Safety precautions. To ensure safety, always verify proper grounding before testing. Avoid touching any live parts. Use PPE to protect yourself, including HV-insulated gloves and face shields. Ensure that all safety protocols are in place, such as lockout, tagout, and PTW procedures. Ensure the SPAJ 142C relay is isolated from the system before testing. Verify the correct SPAJ 142C relay settings before current injection. Required equipment and tools. Overcurrent cpc100 for injecting control current and voltage signals for testing relays protection. Multimeter for auxiliary voltage and wiring checks. 24V DC auxiliary power supply for SPAJ 142C relay. Appropriate cables for secure connection to the cpc100 and to the relay's terminals. Earthing stick to discharge the test line. Controlled environment for safety. Verify that all test instruments are calibrated and fully functional. Wiring diagram for overcurrent testing. Identify test points. Connect 24V DC to the relay's relay auxiliary power terminals 61 and 62. Connect the cpc100's current output terminals to the relay's current input terminals for line 1 phase current 1 and 3 as per relay wiring diagram. Connect the cpc100's binary input terminals to the relay's trip output trip, no normally open terminals 65 and 66. Configuring SPAJ 142C relay for overcurrent testing. Turn on the SPAJ 142C relay. I'm set low set overcurrent to 0.5 amps. K, set time multiplier to 0.5 second. I'm set high set overcurrent to 4 amps. T, set operate time for high set overcurrent to 0.05 seconds. Configuring cpc100 for secondary injection. Turn on the cpc100. Select Test Mode. On the cpc100, choose the secondary injection test mode. Set parameters. Input the desired current magnitude, phase angle, and frequency corresponding to the relay settings. Injecting the test current for overcurrent testing. Low set overcurrent. Inject a current slightly below the relay's set start current. The relay should not operate. Increase the current to slightly above the set start current. The relay should issue a start signal after the preset start time. Maintain the current and measure the operate time. Verify it matches the set operate time for definite time or the calculated time for inverse time settings. High set over current. Inject a current above the high set start current. The relay should issue a start signal after the preset start time. Measure the operate time and confirm it aligns with the relay settings. Should issue a start signal after the preset start time. Measure the operate time and confirm it aligns with the relay settings. Wiring diagram for earth fault. Identify test points. Connect 24V DC to the relay's relay auxiliary power terminals 61 and 62. Connect the cpc100's current output terminals to the relay's current input terminals for earth fault current 25 and 27. Connect the cpc100's binary input terminals to the relay's trip output trip, normally open terminals 65 and 66. As per relay wiring diagram. Configuring SPAJ 142C relay for earth fault testing. I'm set low set earth fault current to 0.40 amps. T set operate time for low set earth fault to 0.10 seconds. I high set earth fault current to 0.10 seconds. Configuring cpc100 for secondary injection. Turn on the cpc100. Select Test Mode. On the cpc100, choose the secondary injection test mode. Set parameters. Input the desired current magnitude, phase angle, and frequency corresponding to the relay settings. Injecting the test current for earth fault. Earth fault protection. Inject currents to test the low set and high set earth fault stages. Verifying start and operate times as per the relay's configuration. Measure the operate time and confirm it aligns with the relay settings. Result analysis. Compare the relay's response times and operation to the expected values based on its settings. Document any discrepancies for further investigation. Understanding and comparing relay characteristics. The SPAJ 140C relay offers multiple inverse time characteristics, including normal inverse, very inverse, extremely inverse, and long time inverse, compliant with IEC 60255 standards. These characteristics define how the relay's operate time varies with the magnitude of the fault current. For a normal inverse characteristic, the operate time can be calculated using the formula, where T is operate time in seconds, K is time multiplier, I is measured current value or fault current, I is set start current value. Alpha and beta are constants specific to the chosen characteristic. For the normal inverse characteristic, alpha equals 0.02. Beta equals 0.14. By plotting the operate time against multiples of the set current, you can visualize the relay's time current characteristic curve. This curve helps in coordinating protection devices by ensuring selectivity and proper fault isolation. For detailed characteristic curves and further technical information, refer to the SPAJ 140C Relay Manual. Warning: always ensure that testing should be conducted by qualified personnel familiar with protection relay systems, and that all safety procedures are strictly followed. Attempting these without proper training and safety precautions can result in serious injury or death. Do not try this at home or without the necessary expertise. Powertech Insights is not responsible for any harm or damage caused by improper handling of electrical systems. Stay safe. Thank you for watching. Don't forget to like, share, and subscribe for more expert tutorials. See you in the next video.